Dear students, today is our second lecture about physicochemical process water treatment. In previous lecture, we just have a brief introduction, but we are going to study this process and what are the different processes, different steps of treatment in which these processes are involved. In today's lecture, we will be moving forward and we will be focusing on the uh, different characteristics which will be involved in these processes. So basically, it is not a simple process of treatment, but it is a complex process in which different types of activities and processes are continuously taking place. And all these processes depend upon the uh, typical nature of the chemicals present inside it. That's why we need to first of all characterize our water and wastewater both. So today's lecture we is going into detail. We will be having a brief look into the sources of pollution and so that we can understand what kind of characteristics water can. So for it is about the introduction to physicochemical processing, unit operation, chemical properties. So what is basically water treatment? It is the water is changed in its characteristics through the industrial processes because in our natural water, naturally existing source water characteristics are, but in if the waste is being disposed into the drain or river, in it is going to completely change the characteristics. That's why we will be talking about the intrusion and disposal of all these chemicals coming from different sources. So what are those sources? Those sources are normally uh, industrial sources, domestic sources. So this is a picture in which you can see different sources at the same time into our environmental system. You can see that there is a variety in it coming from the domestic wastewater facility, and at the same time our sewer is constituting of a combination of different kinds of wastewater coming from different sources. So this is called a combined wastewater and a store source. And then once it is being disposed, it has been disposed into the drains, then it is completely changing the characteristics of the water body. And especially as this is our source, and you can see it's having a wide range like disposal and leakage and directly dumping. So ultimately, whatsoever and maybe you are simply adding up into the system non-required, unwanted chemicals. So this intrusion and addition into a system actually disturbs the whole balance. And especially when effluent is involved, you understand that there is a variety of chemicals which are non-biodegradable. So we need some specific and target-oriented solution for that purpose. That's why the study of the physical is important, and the significance of these processes directly involves the quality of treatment which we are going to obtain in the final stages of treatment. So that's why, first of all, we should have a clear identification of the source from where the wastewater is coming. Secondly, we should have a clear understanding about the characteristics of that water. water and water both. So once the effluent has entered into a water body, it has converted it into a wastewater. So unless you treat it according to its required further usage, so if that water is to be used for drinking purpose, or it is going to be used for agriculture purpose or some other domestic purpose, then it is up to that usage that what quality is required. So first of all, we are concerned with the source. Secondly, we are concerned with the characterization. So both these things are important to understand what kind of treatment is required, so that we can finally use that water for the uh, required usage. Now, if we talk about the different methods which we normally adopt, you can understand that it is an overview of the picture which we talk. So we have the recycled water usage, and then before that we have treatment, and then we have the purification, advanced treatment. This is what I was talking earlier, that we should understand what kind of treatment is required, and then uh, we will be further recycling for the specific. So water treatment is any process that improves the quality of water to make it more acceptable for a specific end use. So this is what we are talking. Water treatment removes contaminants and undesirable components or reduces their concentration so that the water becomes fit for its desired end usage. And what can be end usage? Drink, industrial water supply, irrigation, river flow maintenance, water recreation, or many other uses, including being safely returned to environment. There are three primary methods of water treatment. I'm sure you already have a good vision about these treatment methods: biological, chemical, physical. So this was all about the basic introduction, what we are going to do. So now we move forward to the processes and operations. Starting from the very basics, you know that our treatment process is a combination of physical, chemical, and biological which can take place simultaneously, and they can take place in parallel. And second option is that they can be in a sequence. So it is because these processes are taking place throughout the procedure of treatment, that means it will be involved in different, so like this coagulation, oxidation, sedimentation, filtration, disinfection, and fluoridation, storage. Again, this is a flow chart about the previous slide. And so back to our focus, what was that? It is about the characterization. We should know what types of pollutants there are. I think you know these are organic pollutants, pathogens, nutrients, agriculture runoff, suspended solids, sediments, which can be organic and inorganic, inorganic pollutants, salts, and metals. Then thermal pollution, radioactive pollutants. So organic pollutants are can be further classified like oxygen demanding waste, considerable concentration of biodegradable compounds either in suspended or colloidal or dissolved form, domestic and municipal sewage, wastewater from food processing industries, canning industries, slaughterhouses, paper and pulp mills, tanneries, breweries, distilleries, suspended and colloidal particles. You can understand what is a suspended particle. A heterogeneous mixture that contains solid particles sufficiently large for sediment. colloidal particles, which are weight both, and then they need some driving force to move them to the settlement, to the sediment. So the suspended particles are smaller and do not settle. This is what we are going to target, these colloidal particles. Initially suspended particles, these are already existing and they can have a variety of the density. And then uh, we have a category of particles which is again in suspension, but they are much smaller, and then they need to be collided, they need to be mixed and merged with other particles so that their density and volume increase sufficiently enough to make them settle down by the force of gravity. And then settles down, we are supposed to provide them sufficient driving force. So we need to provide a path. So it will be talked in the coming lectures, and that we can understand the procedure of sedimentation and colloidal particles and how make them settle down in the bottom uh, of the sediment. Then why organic pollutants matter? So usually the organic pollutants decompose by bacterial activity. The dissolved uh, oxygen available in the water body for uh, for aerobic oxidation of organic matter present in the wastewaters. Hence, depletion of the dissolved oxygen will be a serious problem. And then, once the CO2 is reduced, that means the bacterial activity cannot be activated. But which is our main target? Because we will be using bacterial activity to consume the organic pollutant, and that is our major source of adversely affecting aquatic life if DO falls below 4 milligrams per liter. So, the decrease of DO is an index of pollution. The higher the rate of uh, dissolved oxygen, it means sufficient quantity of oxygen is there. But as the DO is decreasing, it means that that oxygen level is being consumed by the bacteria, microorganisms, in finally decomposing the organic content. So that means higher the DO, the better the degrees, lesser the DO means the index of higher. So some of the organic components which cannot be treated by microorganisms. For that purpose, there is some special treatment. So these are the options which we are having for these non-biodegradable synthesized organic compounds. Um, are the refractory organics, and they are resistant to degradation. So PCBs are used in the industry, and I think these are the topics we have already studied in our course, advanced wastewater engineering. That actually focuses on the characterization and so in that course you have gone through all the characteristics and the relevant methodologies, and how UD, is involved, and what is their function to decompose the content of organic material. So all these things you have already gone through. We are just making a scenario to lead to our processes. So unless you understand the basic characteristics, it will not be easy to understand the process. So Please go through the content. Hopefully, you will understand. And you might have gone through the SAG. That SAG curve is actually the disposal of organic content into the drain or water body. And uh, if you note the DO level at the moment when the effluent is adding into the water body, and then gradually you follow the concentration after that, the DO level will reduce significantly, and then it will again rise up. So this is going to develop a sag, was a sag curve, and this sag curve is actually going to indicate how much treatment is required within that water body. Hope you understand the concept of sag. Please consider it as an homework. Go through the DO sag, all oxygen sag in our water body. Focus on it. Please go through the content. It is very simple and very interesting. The DO level is going to vary after the addition of effluent into that water. These are some of the contents which are present in our wastewater oil. Uh, I don't think it's good waste time on just reading the content. Please go through these nutrients and then their effect. So I am sure you are well familiar with this concept of uh, hemoglobinemia, which is a disease which is caused due to the uh, presence of nitrate in our water. If the nitrate content is higher in our water, that means that nitrate is going to affect hemoglobin in our blood. Particularly, this disease is very common in small kids, and usually the babies get uh, suffering from these diseases because of the higher nitrate concentration. That concentration actually uh, uh, reacts with hemoglobin rather than carrying the oxygen. So, hemoglobin is the major component which is responsible for carrying the oxygen from the lungs, and then it is carrying all the parts of the body. But in blood is having higher level of nitrates coming from the water source, it means it is going to affect the level of uh, uh, efficiency of hemoglobin to carry oxygen. So that's why the color of the color of the babies turn blue. That's why this disease is called blue baby syndrome, and this is very common in areas where nitrate level is higher in water, in drinking water. Babies are suffering from these diseases. Please go through it again. This is again the effect of nutrients, which is actually leading to the uh, phenomenon called eutrophication. Understand this term eutrophication, please go through the content, and I'm sure eutrophication is very much involved in this is relevant to the nutrient level, which is so. What actually constitutes nutrients? It constitutes of nitrogen, phosphorus, potassium, and all these things are these minerals and nutrients are actually present in water. But what are its implications? It actually leads to the facilitation of higher growth of algae, because when algae algae, the food of algae is nutrients, nitrogen, phosphorus. So if we are having higher level of like nutrients, that means uh, there will be more growth of algae. If you see the wastewater treatment plant, just in the end, just in the last ponds which are relevant with the facultative ponds, uh, the color of water is green due to the algal growth. That algal growth means that in water now then only the nutrients are in excess. Previously, all the organic and inorganics have been removed in the initial ponds, and now we are left with only nutrients which are nitrogen, phosphorus, which is the food for algae. Algal growth is facilitated in those ponds with green color. So if same process is uh, left unchecked, it will be leading to the excessive growth of algae, and because of that growth, there will be a thick layer of at the surface of any water body. That thick layer, the penetration of sunlight to the lower layers of that water body will be not possible. Therefore, uh, there will be lack of dissolved oxygen in the lower layers, and because of that, the growth of fish and other aquatic life will be in trouble. At the same time, the top layer algal growth will gradually uh, settle down after the uh, completion of the growth curve, which I think you already know growth curve, and due to that continuity and because of the continuous growth of algae in the top layer, the finally the algal growth will start filling up the whole lake, and gradually the whole content of algae existing and that will start dumping in the uh, bottom of that lake or water body. So this is the concept of eutrophication. Please go through this phenomena as well, eutrophication. Then we have some uh, other components like suspended solids and sediments. Suspended solids and sediments you can go through. So inorganic pollutants are here. So now we'll be talking about water quality. Basic water quality parameters are pH, TDS, electrical conductivity. Then we have uh, different ions like sodium chloride, boron, which can be toxic to the plants, and then concentrations of bicarbonate ion, and then carbonate ion. Then we have sodium adsorption ratio, and then we have concentration of plant nutrients in particular nitrogen, phosphorus, and potassium. Residual chlorine, potentially detrimental to the growth of plants. Go through it, please. So I think this is the basic and parameter for all the analysis and determinations and testings. So pH, what is pH? Basically, it is a negative logarithm of hydrogen ion concentration present in water. So what actually it reflects? It reflects the hydrogen ion concentration. What level of hydrogen ion concentration exists in the sample? That's what. And most of the processes, every process is uh, some- having an impact with the change in pH. It is a very important and crucial parameter. Uh, so most of the processes take place at a very at a, acceptable level of pH. So sometimes it is acidic, sometimes it's basic. So to maintain the required pH to complete a physical, chemical, or biological process is very important while dealing with the treatment. So please understand the importance of why it is so important. So this is how it works. Basically, H2O has an equivalent is at equilibrium level with its hydroxyl and hydrogen ion concentrations. And finally, if we consider this equilibrium condition, and it will be giving us a constant of ionization, and that constant of ionization is actually going to give us a K value, and in most of the cases you can relate it with a about 10 to power minus 7 moles of hydroxyl ions produced simultaneously. So by substitution into the equilibrium equation, we obtain um, this equation which you can see here. Since the concentration of water is extremely large and is diminished so little by a slight degree of ionization, it may be considered as constant. It is again important to understand that uh, there is a huge quantity of water, and if you consider moles of water, it will be again very high level of concentration of hydrogen and hydroxyl ions. So the differentiation and movement from one form to the other will be very much uh, neglectable and negligible. So please go through this, and this is the ionization constant 10 to power minus 14. This is known as ion product of ionization constant for water. When an acid is added to water, ionizes water, water activity uh, increases. Consequently, the hydroxyl activity must decrease in conformity with the ionization constant. Both are supposed to balance each other. So, if an acid is added, it is going to increase the H plus to this level, and OH must decrease to this. And why is it important? We are supposed to maintain this equilibrium. Then, similarly, in the reverse case, if we are adding up the hydroxyl ion to this much level, the H plus decrease to this level again to maintain this level. So please go through it, and this is some of the examples of acid H. So neutral pH, and then you see human saliva, this, and stomach acid up to 1, and then this is the uh, pH, and then going on to basics. Now we will be talking about water quality in terms of conductivity. And what is conductivity? It is presence of ions, because electrical conductivity can only take place in the presence of ions, and it is going to indicate how much ions are present in our sample. Higher the level of samples, so the ions, meaning there is a higher tendency to carry TDS. So it is going to give us a direct relationship. PC is directly linked with the TDS level, and it will be measured in terms of microsiemens. We have another parameter, hardness, which is uh, this is the property which prevents lather formation, soap, and produce scale in hot water system. It is caused due to multivalent metallic cations. These ions react with soap to form precipitate, thus reducing the efficiency of soap to form foam and function properly. So I think you have already knowledge about it. Carbonate hardness and non-carbonate hardness. Carbonate is due to bicarbonates which is associated with minus. Non-carbonate is about nitrates, chloride, sulfate. So rainwater is incapable of dissolving. Soil water becomes highly charged. So just please go through it. Sodium. So it is the basics. We must know what is soluble and what is insoluble. Calcium carbonate is insoluble in water. Calcium bicarbonate is soluble in water. So because of this, when we are going to develop this carbonic acid, uh, because of the H2O and CO3, CO2, the pH of the surface reduces. Now, carbonic acid, this one, reacts with the lime formation, calcium carbonate, to form calcium carbonate. And in this case, you can understand that calcium carbonate is insoluble in water, and finally, unless it converts into bicarbonate, it cannot be uh, once it is dissolved. That means it is only possible at the level when it is calcium bicarbonate. And temporary hardness, how you can differentiate? This is a simple test. Scaling not formed if water is boiled, and there is no scale formation at the bottom, it means it is temporary. And then for the permanent one, uh, it is due to the chloride and sulfate ions of calcium and magnesium. There is a scale formation. Just check it. Check the scaling at the bottom. So scaling means it's permanent hardness. Permanent hardness is due to the chloride and sulfate. This is the method through which we can determine the hardness. So this is all about the calculations. You have conducted it so many times, practical, particularly at college level and then in graduation level. Please go through the process. It's kind of your assignment. So what is alkalinity? This is the ability of water body to resist acidification. So please go through the process as well, and both alkalinity and hardness are having the same pattern and of determination. Alkalinity is generally attributed to the amount of carbonate and bicarbonate in water, and it is measured in terms of calcium carbonate. Alkalinity is a chemical measurement of a water ability to neutralize acids. So this measuring the capacity of buffering. This is the first process which acidification is conducted. Carbonic acid is formed like this. It further dissociates into H plus and HCO3 minus, and then furthermore it is separated into the carbonate ion. This carbonate is insoluble as I we studied previously. Now once it is insoluble, that means it has the possibility to be removed. That's it. Please go through it, and it's kind of repetition. So these are the different types of alkalinity: caustic alkalinity, carbonate, and total alkalinity. So caustic alkalinity is at pH 10 to 11, and it gives alkalinity due to the hydroxyl ions. So 2OH plus H2SO4 is going to break this acid, and then it is going to conduct this H2O and sulfate ion. Then we have carbonate alkalinity, the strong amount of strong acid required to to lower the pH of sample to 8.3, and using also known as phenolphthalein alkalinity, it gives the amount of carbonate ions and indication of OH presence. If OH ions are present in the sample, the titration to pH 8.3 will indicate the alkalinity to all hydroxyl ions plus one half of the carbonate ions. So this is also called half alkalinity. Now total alkalinity is bicarbonate alkalinity in amount required to reduce the pH to a 4.3. Uh, the amount of acid required is determined, and it completely converts the carbonate plus any bicarbonates to the carbonic acid. So finally, we are getting this H2SO3, and we have reduced the pH from this level to this level. This is about the measurement of it was about the ability to neutralize the acid. So it's kind of a buffering capacity. You can see that we are continuously adding up the acid to reduce the pH level to this much level. So naphthalene alkalinity is first of all determined, and uh, you can see that we are expressing the result in calcium carbonate terms. Alkalinity is measured in equivalents per liter multiplied by 1 mole calcium carbonate divided by the normality of the calcium carbonate. So what is normality? It is the charge on this metallic cation Ca multiplied by the molecular weight of the calcium carbonate over its molarity, and again multiply. This is the balancing of the equation, and in the end we will be getting alkalinity in terms of milligram per liter as calcium carbonate. The units of magnesium, milligrams per liter as calcium carbonates are for convenience only, allowing you to understand how much calcium carbonate you would need to create a solution with the same alkalinity as sample. So these are the equivalent weights which you will be required to complete that process of calculation. This is an example. Please go through it. Homework. When the alkalinity, why is alkalinity measured in terms of calcium carbonate? Describe the method, and what is the complex titration? How hardness can be calculated through it. So this is all about the today's lecture. Please go through it. It was very basics about the characterization. We will continue this topic in the upcoming lectures as well. Thank you very much for your time today.